Let's take a look at a couple examples using angle pair relationships. So we went over the 5 pairs of angles, which were complementary, supplementary, adjacent, linear pair, and vertical angles in the last video. So let's actually go ahead and take a look at how these are going to show up in examples. So in this first example, it just wants us to find the measure of all 4 angles. So we need to look at the picture and decide what type of angles we see and then figure out what the formula is. So analyzing the diagram. So we see these two are across from each other and we see these straight lines. So that's going to be what we talked about as vertical angles. So I would go back to your notes and then write down the formula for vertical angles. And the formula for vertical angles was that piece equals piece because our vertical angles are congruent to each other. Then you can go ahead and fill in because now we have expressions. So we don't just have, it doesn't just say 100 degrees and we can just say, cool, it's 100. You have to actually go and solve this. So we need the equation that connects them. So we're going to go and put 5x plus 3 equals 3x plus 51 into the blanks here. And then go and solve that. So let's see. So you have x's on both sides, so I don't care what you do first. If you want to bring your x's together or your numbers together, I'm going to bring my x's together. So I'm going to bring this 3x over by subtracting 3x from both sides. So then I'll be left with 5x minus 3x, which is 2x, plus 3 on the left equals 3x minus 3x is 0, so just 51. Then of these two terms, the 3 is a like term with the 51, so I'll subtract 3 from both sides to get my x term alone. So we'll be left with 2x on the left and then 48 on the right. Now that we have all of our x's together and alone, we will divide by 2 to solve for it. So 48 divided by 2, we get 24 for x. So now we've unlocked this missing puzzle piece of the diagram. So we can go ahead and plug this in to figure out how big these angles actually are. So we're going to go ahead and do 5 times 24 plus 3. So 5 times 24 is 120 plus 3 is 123 degrees for that angle. I'm going to actually just quick draw another diagram down here to plug in to make it look a little bit simpler. So that angle right there was 123 degrees. Now remember, we know vertical angles are equal, so this one should be 123 as well. I do still like to go ahead and plug the 24 in and just make sure, in case I did something wrong. So 3 times 24 is 72, plus 51 is 123. So we're good. That means we did our algebra correctly. So now how do we figure out these other missing angles over here? Well, if you take a look, you've actually got a straight line here. So if we take a look, we've got this straight line. And we've got 2 angles making up that straight line. So if I just kind of ignore this other half of the diagram. So let me color this in here for you. So you've got this angle that we already know as 123. Then we've got this other piece right here that we're looking for. Together, those two make a straight line, meaning that they total 180 degrees. So these 2 angles together total 180. So all I need to do is do 180 minus 123, and I have that missing angle of 57. So this angle right here is 57 degrees, and then this one across from it is just another vertical angle. So this one is 57 degrees as well. So then you have all 4. Okay, next example, it gives us the measure of 2 angles. So we've got measure of angle 1 is this, measure of angle 2 is this. Determine the measure of each angle if they are complementary. So go back to your notes and take a look at what the formula was for complementary. And that was blank plus blank equals 90. So you can go ahead and fill in your two expressions here. So we have 12x minus 14 plus 4x plus 8 should total 90. So go ahead and simplify the left here by combining your like terms. You've got 12x and 4x, which is 16x. Negative 14 and 8, which is negative 6, equals 90. Then go ahead and solve. So of these two terms, 16x and negative 6, the negative 6 is a like term with the 90. So we'll go ahead and add 6 to both sides. So then we end up with 16x equals 96. So then you can do 96 divided by 16, so divide 16 to both sides. And you get x equals 6. And then just be careful because it did say that it wants us to find the measure of each angle. So you need to go ahead and plug into each of those angles. So if we take a look at the measure of angle 1, that one was 12 times x minus 14. And the measure of angle 2 was 4 times x plus 8. So I'll plug into each of those. So x was 6, we'll just take and plug that in. So 12 times 6, which is 72, minus 14, which is 58. So we get 58 degrees for angle 1. For angle 2, 4 times 6, which is 24, plus 8, which is 32 degrees. Then you just want to make sure that they are complementary so that if you did anything wrong, so just do a quick check of is 58 plus 32 90, and it is, so you're good. In this one, so we've got two angles are supplementary, so make sure you think about the supplementary formula. So I'm going to just write that out first. Blank plus blank equals 180. So supplementary means that they total 180. Now this one says, given that one angle is 5 times bigger than the other, determine the measure of each angle. So we don't know either angle right now. So the first angle I'm just going to call x because I don't know how big it is. Then the other angle is 5 times bigger than that. Well, it's 5 times bigger than x, so 5x. So we've got one angle x, the other one is 5 times bigger than it, or 5x, and they are going to together total 180. So x plus 5x is 6x equals 180. Divide by 6, and you get x equals 30. Then take and plug this into each angle. So one angle was x, which is 30 degrees, and one was 5 times x, so 5 times 30, which is 150 degrees, and then together those total 180, which is what we wanted. Next example talks about a linear pair. So again, go to the formula for linear pair. Linear pair means two angles that together create a straight line. So I'm actually going to draw you a diagram of this too because these ones have to be touching. So here's what a linear pair looks like. And again, the formula is blank plus blank equals 180. And so we've got one angle is 17x minus 4 degrees, and the other one is 3x plus 44 degrees. So if you were drawing on a picture, it would look something like that. Then we know that when we add these two together, the algebra behind it is that when we add them, they are going to total 180. So this is what your equation would look like. Again, combine like terms. So we've got 17x and 3x. So we have 20x. We've got a negative 4 and a positive 44, which is positive 40. And that is totaling 180. $20x and 40. The 40 is a like term with the 180. So we're going to subtract 40 from both sides to get those together. So we get 20x is equal to 140. Then we're going to divide by 20 to both sides and get x equals 7. Then remember, this one wanted us to find the measure of each angle. So once we find x, we need to plug it back in. Okay, so for the measure of angle A was 17 times x minus 4. The measure of angle B was 3 times x plus 44. So we can just plug that in. So 17 times x was 7. So 17 times 7 is 119. Minus 4 is 115 degrees for the measure of angle A. So for angle B, 3 times x is 7. So we get 21 plus 44. So the measure of angle B is 65 degrees. And then check that those two total 180 degrees, and they do, so you're good. So that's using angle pairs. Then the other thing that I want to talk about here is what you can and cannot interpret from a diagram, because when we're looking at pictures like we did in that first example with vertical angles, you have to know specific things about the picture. There are only certain things that you can get from a picture without markings. So when you're looking at a diagram, the things that you can just see in a diagram without needing any extra markings are like the position of something. So whether a point is inside or outside of an angle, if it's interior or exterior, you can tell if you have a straight line. Okay, so if a line is straight on the paper, it is a straight line, meaning you know that it's 180 degrees. That's a big one, okay, because that gives you a number by seeing a straight line. You can tell if angles are acute or obtuse pretty much, okay? If they're like this, you know it's acute. If it's like this, you know it's obtuse. If it's somewhere really close to 90, then you may not be able to tell that. You can tell adjacent angles, so you can tell when angles are touching. You can see where things are intersecting, so if lines are crossing, you can see where they cross. And you can see vertical angles because you can see straight lines. So like we did in this example, we know that these are straight lines, okay? So we know that those were vertical angles. Things that you can't see without having markings is anything to do with measurement, okay? So you cannot tell if lines are congruent without markings. You cannot tell that an angle is 90 degrees without markings. You cannot tell that angles are congruent without markings. So you need to be really, really careful. The only numbers you can really tell without markings is a straight line at 180 degrees. Otherwise, there has to be markings on the diagram, or it has to be told to you in the problem. So if we take a look at these two different pictures, so this one you can tell very little about the diagram because there are no markings. So you can tell that this is a straight line. Okay, so we can tell that A, B, and C are collinear points. They're all on the straight line. You can see the rays and the arrows. You know that this is 180 degrees because of it being a straight line. You can tell that E is on the inside of angle DBC. You can tell that angle BCE, this angle here, and DBE are adjacent to each other, so you can tell that they're touching, but you can't tell anything about measurements in that picture. Okay, where if we go to this picture on the right, now you can tell a ton of stuff, okay, because there's all sorts of markings here. So you can tell that AB is congruent to BC. So we can tell that those two segments right here are equal because of the tick marks. You can tell that the measure of angle ABD is 90 degrees because of the right angle. You don't know that here, okay, because there isn't anything here showing you that this is a right angle. Have to have a mark for that. You can tell that these two angles here are equal. So we can tell that the measure of angle DBE is equal to the measure of angle EBC because of those arc marks. Okay, you also know that this angle, so since you know that this is 90, then you know that this side is 90 as well, since a straight line is 180. And then if these two are equal because of these arc marks, you could divide them by 2, and that's actually 45 for each of those angles. So in this picture, you can see a lot of information because of the markings. Over here, it would be inappropriate and false to say that AB is equal to BC. No matter how much they look the same on the picture, if there are not markings, you cannot tell that. Okay, so be really, really careful. So things you can see are straight lines, position, and that's about it, okay? You have to have markings for anything to do with actual measurements.